2 years ago today, I got a tattoo of the unit circle.
Is your first year?
Maybe. Plastered on my chest is a concept that to many exists only as a horror story from pre-calculus. So, while I wish people's first response was, "Wow, JJ, that's so cool," it typically isn't. In the last 2 years, I've lost count of the amount of times I've been asked the question, why? When I was in 6th grade, I was part of the math team at my middle school. Big surprise, I know. While struggling with a problem, an older peer told me, if you can't find an obvious solution, look for a right triangle. Trust me. At the time, I didn't trust him. As time passed, though, it became more and more obvious that triangles really were the most reliable and consistently arising tools in math and physics. Slope is just a right triangle with the sides rise and run. Derivatives are just infinitely small triangles that open the doors to the magic that is calculus. Complex numbers exist in a literally imaginary plane, and yet, with the help of right triangles, we are able to work with them seamlessly. Even rectangular coordinates in any dimension greater than 1 can be broken down into constituent right triangles. So, right triangles are everywhere. And there is one tool where all right triangles are accounted for and seamlessly cataloged. That tool is the unit circle. It's a simple circle with a radius of 1 and a circumference of 2 pi. And it outlines every single right triangle with a hypotenuse of 1. But anybody can group a bunch of shapes together. What makes the unit circle special? The answer lies in another one of math's most notorious concepts, trigonometry. It's not revolutionary to claim that trigonometry is important. Trig bridges a critical gap between angles and side lengths, and not for just right triangles. The law of sines and the law of cosines make it possible to take any triangle you could possibly imagine and do operations on it to find side lengths and angles. Trig functions exist in a strange mental space for students due to their unique behavior. This makes it even more beautiful that the same tool that catalogs all right triangles also catalogs how they interact with the trig functions. If you remember from pre-calc, every point on the unit circle is associated with the triangle. This triangle's x and y coordinates corresponds with the cosine and sine of its angle. Let's think about this for a second. You're telling me that 2 of the most prevalent concepts in math are combined in one simple circle? That's incredible. If there is intelligent life anywhere else in the galaxy, no matter how far away, due to the stone-cold certainty of the ratios and values held in the unit circle, their trigonometric functions are exactly the same as ours. While I could talk all day about the things like wave nature of matter, complex unit circles in Euler's proofs, and the sinusoidal behavior of electromagnetic waves, I will leave you all with this. Next time you encounter a trig problem or ponder the irrationality of pi, be grateful that the nature of the universe follows such strict and predictable guidelines. Be fond of the simple elegance of the unit circle. And if you encounter a problem that doesn't have an obvious solution, try to find a right triangle. Thank you.